Hi, I'm Sion, the Unexpected Maker. I'm currently reflowing thousands of PCBs, and when you reflow PCBs in a reflow oven, the solder paste produces flux fumes that are stinky and toxic, and breathing them in over a prolonged period of time is extremely harmful for you. So I've been trying to find a solution to reduce the stink in my office and in my work area, and obviously remove the toxic fumes so I don't make myself sick. And I think I've come up with quite an elegant and simple solution that I can use both inside my office and inside my garage. Let's have a look at what I bought. What am I going to use for the project? This big tub. So the tub is quite large, as you can see. It's quite high. It's about twice as high as the unit, or not quite twice as high. It's about this high. There's a little bit of room, which is great. It's longer than the unit and it's wider than the unit. So this will be perfect to go over the top of the oven, and the idea is I will cut into the top here or maybe the back here to put an exhaust fan. I'll be able to cut vents into the side down below to make sure air can come in. I don't want to completely restrict the air inside. And well, the wheels I can just always pop off. This is definitely something that is easy enough to try with. What else did I get? Well, I've got an extraction fan. So this is something that's generally used with hydroponics, and it's got 3 different speeds. It's 100mm or 4-inch connection. Now remember, I don't want to pull too much air, right? I don't want to cool down the unit while it's reflowing. I just want to move hot air out, so I don't need it to be super fast. And the fact that this has got 3 different speeds means that I can play around with how much air I'm taking out and still be able to get the hot air and the fumes out of the system. So to connect to that, I've got a bunch of ducting hose. So this is insulated ducting hose, and it's also got this black plastic on the outside to help keep the heat in. So it's a little bit more durable than just the straight aluminium hose that you can get. Got 2 lengths of that, and I also got something that I wasn't expecting to get. I got a carbon filter. So this is again designed to work with this system. It's got a 100mm outlet, or 4 inches, and these are designed to be disposable. They're expensive for disposable, they're about $75, but they're designed to, well, let's face it, they're designed to remove the smell of things like marijuana and stuff like that when you're growing, when you're not supposed to be. So this will have the advantage of not only scrubbing the air and getting rid of the flux toxins, but it'll also get rid of the smell from the reflowing as well. And for the hydroponics world, this is supposed to last about a year. I don't know if it'll last more than 3 or 4 months for me, but for $75, it's worth it. Because my alternate options are to build an enclosure and use some of these cheap eBay carbon filters that you're supposed to put in front of your soldering extraction fans. These also don't last very long. So I was going to build something that sat between the hose and this, that I could slot these in, but these are fairly useless. This is a much better solution. This will mean that I can leave this inside the office and just have the air go out, and all of this can remain inside. So that's everything I need, except for some 100mm clamps to hold everything together, some cutting wheels for my Dremel so I can cut into the plastic, and last but not least, if it all actually looks okay and works okay, I have a faceplate for the outside of my office to hide the hole that I'm going to have to put inside the wall at some stage. But for now, I'm going to have the hose just go out the door and make sure that everything works okay and the inside of this stays stable before I put a hole in the wall. Okay, let's get to building. Safety. So I want to put a door flap on it so I can lift it up and pull the tray in and out and be able to get to the controls on the front of the unit. And ideally I want the flap to be able to lift up and sit up here. The problem I've got is if I cut it through here, then as it lifts, it's going to be pulling backwards and it's not going to sit nice. I mean, it's going to be a terrible cut anyway. I know it's going to be a terrible cut. It's going to look god awful. But remember, it's just to allow enough suction for the air to be able to be extracted out. So I'm not overly worried about how it looks right now, or even if it only has 60 or 70% efficiency, so long as it works. But having a flap here is a bit of a problem. I'm probably going to have to cut it right on this curve here so it lifts up correctly and have it flap over rather than have the hinge part here, because it's just not going to sit back in properly. I'm just going to use some tape once I cut this out to just stick it back on again like a hinge. Just some gaffer tape. It's going to be a terrible join. I could eventually stick some rubber or something behind it to give it a bit more of a seal. Okay, let's get cutting. So that's the door. It's going to hinge here. Whoop. Almost there. The last thing is need to do the hole. Wow, look at that. Almost a perfect circle. Nuts. Okay, I've given it a bit of a clean. I've taken the sharp edges off, I've given it a sand, so it's ready to keep going. But I've had a bit of a change of plans. I was going to print a 3D printed piece that goes here, that sticks out, that I could attach the hose to. But it turns out that this, that I was going to use for the outside of the office, which I could always get another one for, fits actually quite well inside here. So, I'm going to use that instead. What do you think? Pretty cool, huh? So I need to screw that together. I've already put screw holes in. I hope that they are lined up okay. They look almost okay. Now, unfortunately, the square plate of this is a little bit long and it doesn't go quite to the edge here, so it's on a slight angle, but it's definitely good enough for what I need because it's quite airtight. And again, this doesn't have to be perfect. So I've got some nuts and bolts, and it doesn't really matter if I have the nut sticking out too far at the back, as long as I can get the hose on. What's nice about not having to print a 3D printed piece is I can actually get this up and running today and not have to wait for a design and a print to happen. Perfect. So that is what we're going to attach the hose to. So what do you think? Thumbs up? I think it's almost time to give this a test. I'm going to get the duct hose at the back going off and down, I guess for now, behind the 3D printer, which is on the left, and I'll take it out either into the garage or just out the door for the moment, just to see how it works. And the kick is going to be how much heat stays in, how much heat goes out, and whether it can actually do a proper reflow because of the loss of heat. So let's find out. Okay, this is currently reflowing. It's doing low temp paste. You might be able to hear a bit of a hum. That is the exhaust coming out of the back. It's got no smell at all. I can feel cool air being pulled in from the sides, And warmth here, I mean it's warm, it's not hot. It's maybe 35 degrees, I'd say, maybe 40 degrees. I can see through the crack. It's currently at 122 degrees on the reflow. And the exhaust is coming out. And at the moment it's coming around and to the fan and over to the carbon filter. So all of it is inside my room at the moment. Now this filter has got no smell coming out at all. There's no flux smell. And though the hose is obviously warm because there's hot air coming through, there's very little coming out of this. And it's completely fresh. It's amazing. I would not have expected to be able to completely eradicate all the fumes and all the smell. Now this is not the first time I'm running this. I produced 150 tiny picos on Tuesday using this, doing high temp reflowing and low temp. On Tuesday morning I had the carbon filter in my garage and I had the hose going all the way out to the garage just in case. But I could smell nothing in the garage at all. Without the carbon filter at the end, just the hose going out, the garage stank of flux and the fumes. And obviously having the reflow finished, having the door open a little bit to get the tube out meant that I could get the smell back in again. But then when I put the carbon filter in the garage, no smell at all. So today I've been reflowing within my office to check, and it's amazing. And it's fairly quiet. And I'm only sucking air on the lowest fan speed. I'm completely blown away by how much I've reduced the smell and the fumes. It's incredible. I didn't expect it to work this well. And at the end, we just lift the door up, fold it over, pull it out, and there we have 2 panels of very nicely reflowed solder paste. Now I can smell a tiny bit now obviously because I've just opened up the drawer, but this is like night and day compared to what I used to experience in my office when I was reflowing. So I'm extremely happy with the results of this, even as temporary and ugly as it looks. So I now have a solution. It's sitting inside the garage. I can leave the door open and not have to worry about toxic fumes and smell coming into my office as I'm working, and I can monitor the reflow oven from inside my office without actually having to have it inside the office. Now the main reason I wanted to keep it in the garage is, even though I'm reducing the fumes and the smell, I'm generating a stack of heat. It's running 10 or 15 times a day or more, and my office is getting really, really hot. So moving inside the garage means that I have the opportunity to reduce the heat, have the heat dissipate that way, and be comfortable in my office. Now I'm sure a few people are going to comment about the fact that I used a plastic enclosure around the oven. I did my research about injection molding and the type of plastics used in these tubs and what temperatures they're actually molded at, and they generally start at around 400 degrees for injection molding, sometimes up to 550 degrees depending on the type of plastic. So there's no danger at all in using a plastic tub on the outside of the oven and enclosing it if I'm moving the air out. Overall, I'm extremely happy with the results, and I just wish I would have done it sooner. Thank you for watching. Don't forget to like the video, don't forget to subscribe if you haven't already, and if you have, please click the alarm bell to be notified when I have new videos coming out. Thank you to all my patrons, you're all fantastic, I really appreciate it. If you want to back me on Patreon, there's a link to my Patreon down below. And until next time, catch you later. Bye.